In this video, we are going to look at some questions from Mathematics Paper 1 for the year 2017. Now, this paper was written by the GCE candidates. Now, let's look at the first question. Simplify 2a minus 7b minus 2 open brackets a minus 3b. Now, the first step here, first we need to make sure that we get rid of the brackets. So 2a and 7b will just be written like that. Then the first, this negative 2 should be multiplied by a. So negative 2 times a will have negative 2a. Then the second one, negative 2 will multiply with negative 3b will give us positive 6b. So after we are done removing the brackets, so we can look at the like terms. So from this stage, we can see that these two are like terms, and also these two are like terms. So we can now group them together. So the first one, we have 2a minus 2a. Then 7b plus 6b. Then we know that 2a minus 2a is 0, so we can just cancel this, leaving us negative 7b plus 6b. Then we can do the last operation. Minus 7b plus 6b is just negative b. So this is our final answer. Okay, so now we move on to question to factorize completely. So we have two fractions. The first fraction is this one, and also this fraction. Now we can see that the operator in between is minus. So our first step is, first we need to look at if we can break each variable and number to its perfect square number. So let's look at x. We have x squared. Then for 4 is the same as 2 squared, y squared minus, here we have 1. If we raise 1 to the power 2, 1 times 1 will still get 1, so there is nothing that we've done here. It's the same thing. Then what of 9? So 9 can be written as 3 raised to the power 2. So now we can see that each party has or is raised to the power 2. So we can now use the method of the difference of two squares. So now after reaching at this stage, we are supposed to now open two pairs of brackets. So since we have two variables of x, one will be written here, the other one will be written here, then over. Then we have also two values of 2, one be written here, also one be written here. Two variables of y, one here, one here. So since we have a minus here we are going to have a positive, then here a minus. So the key point is you need to have different signs. One bracket must have the negative, then the other one must carry a positive. Then from the other fraction, we can see that there are two ones, one will be written here, the other one will be written here. Then we have two 3s, one will be written here, also one will be written here. So this is the answer for this question. So now we move on to question 3. Given that matrix 2x negative 1 and negative 5 1 times 4 and 3 is equal to the matrix 14 and 17. Find the value of x. So now let's look at the row where the x is. So from the first matrix, we can see that the value of x is in the first row. So that is our area of interest. So since we can see that from the second row, there is no variable of x, so we'll just use this row where x is times the second column. So let's do the operation. So the operation is the 2 multiply with 4. So we have 2 times 4, then plus the x will multiply with 3. We have x times 3 then is equal to, since we use the first row, we are supposed to use the first number from this matrix after the equal sign, so is equal to 14. Then 2 times 4 is 8. 3 times x, that is just 3x, is equal to 14. So if we collect the like terms, so the 8 will move to this side, leaving us with 3x is equal to 14 minus 8. 3x is equal to 14 minus 8 is 6. So for us to find the value of x, we can divide both sides by 3. Then we can see that now the value of x is equal to 2. So now we move on to question 4. Two things are geometrically similar. If the ratio of their volumes is 27 to 64, find the ratio of their curved surface area. So we have been given the ratio of the volume. So what are we supposed to do? We are supposed to find the cube root, since volume is raised to the power 3. So the cube root, we are looking at the number that we can multiply by the same number, giving us the given number. So in our case, we want the number that we can multiply the same number 3 times to give us 27 and also 64. So if you don't know this number, you can try by, you start from 1. So we know that 1 times 1 is equal to 1. Then if we try 2 times 2 is 4, times 2 is 8. Then if we have 3 times 3 is 9, times 3 will give us 27. Then if we try 4 times 4 times 4, so 4 times 4 is 16. 16 times 4 will give us 64. So this simply means that the cube root of 64 is 4. The cube root of 27 is 3. So these are the numbers that we are looking for. So we need to find the cube root here and also the cube root here. So we know that the cube root for 27 is 3. Then for 64 we have 4. So these are known as the scale factors. So for us to proceed by finding the ratio of their curved surface area, we are supposed to have the scale factor. Now after finding the scale factor, what are we supposed to do with the scale factors for us to find the ratio of their curved surface area? So area is raised to the power 2. So we are going to raise each scale factor to the power 2. So 3 squared, also 4 squared. Then we know that 3 squared is 9, 4 squared is 16. So 9 and 16, these are the ratio of their curved surface areas. So we move on to question 5. Given that the vector A in component form has the element 3 and negative 4, find the modulus of A. So the formula for modulus, so modulus is equal to, you need to write the square root, then x squared plus y squared. So from this vector, the number on top is x, then the other one is y. So from there we can now see that the value of x is 3. So 3 squared plus the value of y is just negative 4. We square it also. So 3 squared is 9. Negative 4 squared is positive 16. Then if we add 9 plus 16 will give us 25. The square root of 25 is just 5 units. So after finding the final answer, you need to add the word units. So since this is just like a distance. Okay, so now we move on to question 6. On the Venn diagram, in the answer space below, shade the region defined by A complement intersection B union C. So this should be C. Now for you to have a clear picture, what you can do, you can draw another Venn diagram. Then from this Venn diagram, try to put numbers from the 3 sets. So we'll say we'll have 1, 2, 3, 4, 5, 6, 7. Now let's first look at let's find the elements of B union C. So B union C is a set that we can form if we combine the elements of B and C. So the elements of B and C will start from 2, then 3, 4, 5, 6, then 7. So this is the set B union C. Now let's also look at the elements of A, set A. So set A has 1, 2, 3, 4. Now from this expression we have A complement intersecting B union C. So what this means is, let's look at we are trying to remove the elements of A, including those that are intersecting between B union C. So here let's look at the elements that are found in the union between B and C and the set A. So the intersection of this, we are saying we want to find the intersection of A intersecting B union C. Then let's look at the complement later on. So what are the elements that are found in this set and also in this set? So we can see that 2, then we'll have what else? 3, then what else? We have 4. So we have 4. Now if we remove these, what elements are remaining? So the elements, if we remove 2, 3, 4, this is what we are going to shade now. So that is the picture. So this is the set of sets that we are supposed to shade. Now we move on to question 7a for the sequence. So we have this sequence 11, 13, 15, 17, dash, dash, dash. Now the question is, we want to find the term on position number 13. So let's look at the number of terms that we have. So we have first term, second, third, fourth, we have the fifth, sixth, seventh, eighth, ninth, then 10th, 11th, 12, 13. So we want the number at this position. So let's find the common difference. So the symbol for common difference is small letter d. Then the formula is second term minus first term, or third term minus second term. So we can see that the second term is 13 minus first term is 11. So if we subtract, our common difference is 2. If we want, we can use 15 as our third term minus second term 13. So 15 minus 13, we still get 2. So this means that they were adding 2 on each term. So like 11 plus 2, 13, plus 2, 15, plus 2, 17, plus 2, 19, plus 2, 21, 23, 25, 27, 29, 31, 33, 35. So this is the number that we were looking at. Now if we want, we can also find the 13th term by using the formula. So the formula is Tn is equal to a plus n minus 1 in brackets multiplied by common difference. So since we are looking for nth term, this tells us that n is equal to 13. So where there is n, we put 13. Our a is our first term, so a is 11. This is our first term, plus c 13 minus 1. Our common difference is 2. So this is equal to 11 plus 13 minus 1 is 12 times 2. So 13 is equal to 11 plus 12 times 2 is 24. If you add 24 and 11, it will give you 35. So you can find the answer by using the formula or by just adding the common difference until you find the position of the number that you are looking for. Now let's move on to question B. If the arithmetic mean of 5 and c is 11, what is the value of c? So the arithmetic mean is the middle term between the 3 consecutive terms in an AP. Now for instance, if we have 2 comma, then if we have 6 here, so the middle number here, this is our arithmetic mean. So the formula is, for us to find the middle term, we need to add these two numbers. So we need to add 2 plus 6 over 2. 2 plus 6 is 8 over 2. 2 into 8 will give us 4. So this is how we find the middle term. Now the question is, if the arithmetic mean, so we have been given the middle term, we want to find the value of c. So the point is like this. The c is on position number 3. Then here we are looking at the middle term is the mean, and we are given that the mean is equal to 11. So here we are supposed to have 11. So what is the value of c? So we can find the value of c in so many different ways, but let's find the value of c by first we find the common difference. So common difference is equal to, this is our second term, this is our first term. So say second term minus the first term. Second term is 11 minus 5, which is giving us 6. So from 5 to 11, 6 was added. So from 11 to c, we need to add 6 again. So the value of c is equal to 17. Then how can we also solve? We can solve the same 17 by using the formula. So we'll say we are looking for the number, the third term, the number on position number 3. So we'll use the formula Tn is equal to a plus n minus 1 multiplied by common difference. So since the number that we are solving for is on position number 3, the value of n is equal to 3. So 3, then our a is our first number in our sequence. So we have 3 plus this should be 5. Our first term is 5 plus 3 minus 1. Common difference is 6. So 3 plus 3 minus 1 is 2. If we multiply 2 times 6 will give us 12. If we add 5 plus 12 will give us 17. So we can find the value of c by using this formula. Or if we want, we can also find the value of c by using the formula for arithmetic mean. Now we'll consider this one as the value of a. We have a, b, c. So the formula for arithmetic mean is equal to a plus c over 2. Now The B is the middle number, we have it is 11. Then A is our first term, 5, plus C over 2. Over 1, we cross multiply. So 1 times 5 plus C is still 5 plus C. 2 times 11, we get 22. So if we move 5 to this side, we get C is equal to 22 minus 5, which is C is equal to 17. So now we move on to question 8a. If A matrix A transpose is equal to this, write the matrix A. So here we want to find the original matrix of A since we have been given the transpose. So from this we can see that we only have this row, so we need to make it a column. So the answer is we are supposed to have 1, -2, 3, -4, 5. So this is our transpose. Now for question B, find the derivative. We have the equation is equal to 2x raised to the power 3 minus 2x squared minus 3x plus 1 with respect to x. So here we are trying to differentiate. So let's look at the first letter is y. So this will be dy over, we are differentiating with respect to x, so over dx. Then we are going to use the power rule. So how do we use the power rule? We move the 3 to the front of x, so this becomes 3x raised to the power 3 minus 1. Minus, we write the constant 2, then we bring our 2 down, so we have 2x raised to the power 2 minus 1 minus 3. Here we have the power of 1, so this will be 1x 1 minus 1 plus the derivative of a constant, which is 1, is just 0. So the power rule is immediately after bringing the power in front of x, you subtract 1. So we have 3 raised to the power 3 minus 1 is just 2. Then we have 2x raised to the power 2 minus 1 is just 1. Minus 3, 1 raised to the power x, 1 minus 1 is just 0. Then plus 0, so you can just ignore the 0. So the point is, after you differentiate, the power reduced by 1. Then from there we can expand. 2 times 3, we have 6x squared minus 2 times 2, we have negative 4x. Then here we are going to have 3 times 1 with 3, then x raised to the power 0. We know that anything raised to the power 0 is 1, so here we just have 1. So our final answer is 6x squared minus 4x minus 3. So this is how we can solve the question for the calculus. So now we can move on to question 9. So question 9a, given that universal set has elements 1 up to 8, then set A 1 and 8, B 2, 3, 4, 5, 6 and 7, list A union B complement. So the idea behind complement is, first we will find the elements of A union B. Then you look at the complement later. So A union B, we want to combine the elements from A and B by making one set. So we can see that it's 1, 2, 3, 4, 5, 6, 7, 8. So this is the set of A union B. Now if we put complement, it means that anything under the set of A union B must not be part of our solution or must be excluded. So for us to find A union B, we need to cancel every element found in A union B. So 1, then we cancel our 2, 3 is there, 4, 5, 6, 7, 8, 8. So we can see that under the universal set, there are no elements remaining. So our final answer is just equal to empty set. Now let's look at question B, and we'll consider this question as our last question for this video. So we have 25 raised to the power x is equal to 5. Now how do we solve an equation like this one? So we are going to use the rows from the indices. So we need to make this base here where this base must be equal to whatever base that we have here. So this is 5 is same as raised to the power 1. So we need to break 25 so that it becomes 5. So 25 is the same as 5 raised to the power 2 multiplied by x is equal to 5 raised to the power 1. Then according to the rules of indices, we can multiply the 2 with x. This will give us 5. 2 times x, we have 2x is equal to 5 raised to the power 1. Now after we are done making the bases to be the same, we can cancel this. Then we'll just consider this part. So our final answer will be 2x is equal to 1. If we divide by 2, also by 2, x is equal to 1 over 2. So this is how we can solve an equation where we have the letter as a power. So that's it for this video. Thanks for watching, and God bless you.